Okay, this is Algebra 2, Year 2. This is 11.3, Day 1, our first assignment that was dealing with independent and dependent probability. So problem number 1 is dealing with our first situation, and it just says that events D, E, F, and G are independent. And probability of D, E, and F, and G are all given to us as decimal answers. And we need to find the probability of each combination of events. So for number 1, we're given the probability of D and E. So if our events are independent, we simply multiply what we're given. So we're going to multiply the probability of D by the probability of E. So that equals, for probability of D, we're given that it's 0.02, and we'll multiply by the probability of E, which is 0.1. And when we multiply this out, we get 0.02. Number 2 is finding the probability of D and G. So that equals the probability of D times the probability of G. Our probability for D is 0.2, and our probability for G is 0.25. When we multiply those two out, we get 0.05. Oh, and it asks us to put these in the percents, rounded to the nearest tenth. So if we take this to a percentage, this is 2% for number 1. Number 2 is 5%. Number 3, we're finding the probability of E and F. So this equals the probability of E times the probability of F. So the probability of E was 0.1. Probability for F is 0.4. When you multiply those out, you get 0.04, which translates to 4%. And number 4, probability of D, E, and F. So that equals the probability of D times the probability of E times the probability of F. So the probability of D is 0.2, probability of E is 0.1, and the probability of F is 0.4. When we multiply that out, we're going to get 0.008, which translates to 0.8%. Number 5 through 8 are dealing with the next section of word problem. So it says a bag contains 3 white marbles, 2 red marbles, and 7 blue marbles. A marble is picked at random and is replaced. Then a second marble is picked at random. Find each probability. So the key word in this problem is that the marble is being replaced. If it's being replaced, these are independent events. So we're just finding the probability of each event and multiplying them. So for number 5, we want to find the probability that both marbles we pick are blue. So we need to find probability of blue. So there are 7 blue marbles, and that's out of, we have 3 white plus 2 red, so that's 5 plus the 7 blue. So we have 12 marbles altogether. So that's the probability of picking a blue marble first. And then we need to find the probability of picking a blue marble second. And again, we're putting the marble back after we've picked it. So we still have 7 blue marbles out of the whole 12. So our probability that both are blue equals probability of blue times probability of blue. So that equals our 7/12 times 7/12, which will give us 49/144, which translates to a decimal of 0.340. Number 6. Number 6 wants to know what the probability of the first marble is white, the second marble is red. So probability of white. So we have 3 white marbles. So that's 3 out of 12. And then we're putting that marble back and we're finding the probability that we get a red. So we have 2 red marbles out of the 12. So the probability that you get a red and a white is the 3/12 times the 2/12. So you're going to get 6/144. Which gives you a decimal of 0.042. Number 7 wants to know the probability that neither is red. So if neither marble is red, they could be either blue or white. So probability not red for the first one. So we have 3 white and 7 blue, so that's 10 out of the 12 marbles. And then again, probability not red. For the second draw, we've put that marble back, so we still have 10 out of 12. So our probability that neither is red is going to be our 10 out of 12 times 10/12. Which is going to equal 100/144. And that's going to give us a decimal of approximately 0.1875. And then number 8. Number 8 wants the probability that the first marble is white and the second marble is not white. So we need to find the probability that the first one is white, so probability of getting a white marble. So we had 3 white marbles, so there's 3 out of 12 for our probability of getting a white marble. And then our second one is the probability that it's not white. So if it's not white, it could be red or blue. So we have 2 red and 7 blue, so there's a 9 out of 12 that it's not white. So our probability of drawing a white first and not a white second is 3 out of 12 times 9 out of 12. So we're going to get 27 out of 144, which is going to give us a decimal of number 7. The decimal, should be 0.694. 0.694. I gave you the wrong decimal, so number 7 should be 0.694. Number 8, you should get the 0.1875. So again, 100 divided by 44 for number 7 gives you a decimal of 0.694. And for number 8, 27 divided by 144 gives you 0.1875. Now number 9 through 11 is dealing with the next situation. So we're rolling, a number cube is rolled twice. On each roll, the number on the top is recorded. And we need to find the probability of each event. So we're rolling the number cube twice. So these are independent events, so we're just going to multiply the probabilities of each event. So for number 9, it says that the first number is greater than 5 and the second number is less than 3. So I like to look at what my choices are for a number cube, and those are the numbers 1 through 6. I just like to be able to see them. It makes it easier to figure these out. So for the first roll, we want to know the probability that is greater than 5. So there's one number greater than 5, that's a 6. So 1 out of 6 chance of being greater than 5. Our second roll, we want to find the probability that it's less than 3. So we have 1 and 2 are less than 3. So we have a 2 out of 6 chance that it's less than 3. So to find our probability that it's greater than 5 and the second is less than 3, we multiply 1/6 times 2/6, and we're going to get 2 over 36, which is going to give us a decimal of 0.056. 0.056. Number 10 wants the probability that both numbers are greater than 4. So we need to find the probability of being greater than 4. So there are two numbers that are greater than 4. So we have a 2 out of 6 chance of being greater than 4. And for the second roll again, it would be greater than 4. So we should get the same probability, 2 out of 6. So to find out if both numbers are greater than 4, we're going to take 2 over 6 times 2 over 6. You'll get 4 over 36, which will give you a decimal of 0.111. And number 11. The first number is even and the second number is odd. So probability of even gives us, there are 1, 2, 3 even numbers out of the 6, and probability of odd, there are 1, 2, 3 odd numbers, so 3 out of 6. So we're going to multiply these, 3 over 6 times 3 over 6 gives us 9 over 36, which gives us 0.25. And again, all of these numbers could be converted to decimals simply by multiplying by 100. All of our decimal answers that we got for all of our problems could be converted to percentages. Now, on the back page, number 12. Number 12, well, before number 12, it says a number cube is rolled and 2 coins are tossed. Find the probability of each event. So number 12 says the number on the cube is 2 and both coins are heads. So now we have 3 events. And again, we know that our number cube has the numbers 1 through 6, and our 2 coins can be either heads or tails for both coins. So we need to find the probability that the cube is a 2. So there's a 1 in 6 chance of it being a 2 because there's only 1 2. And then we need to find the probability of heads on the first coin, probability of heads on the second coin. And we have a 1 in 2 chance of getting a heads on the first and a 1 in 2 chance of getting heads on the second. So again, these are independent events. So we're going to find out if it's a 2 and both coins are heads, we're going to multiply through. So we're going to have 1/6 times 1/2 times 1/2. That's going to give us 1 out of 24, which is going to give us a decimal of 0.042. For number 13, it wants the number on the cube is even. One coin shows heads and 1 coin shows tails. So probability of an even number on the cube is 3 out of 6 because there are 3 even numbers. Probability of getting heads on the first coin is 1/2. And probability of getting tails on the second one is 1/2. So again, these are independent events, so we're going to multiply through. So we're going to have 3/6 times 1/2 times 1/2. And that's going to give us a decimal of 0.125 when we multiply through. Number 4. The number on the cube is greater than 2, and the coins show different sides. So number 14 is kind of complex to think about, and I won't ask you a question like this on your test, but it's good to know. So we need to find the probability of getting greater than 2. So there are 4 numbers greater than 2, so it's 4 out of the 6. Then we need to find the probability. So the coins, it says that they show different sides. So probability of the first one, of the first coin, it could be either heads or tails. So you have a 2 out of 2 choice is your probability, because it could be either one. But then the probability for the second coin, we would want it to show the opposite side. So you would only have a 1 in 2 chance to get whatever the other side would need to be for that one. So then we're going to multiply through these numbers. So we're going to have 4 out of 6 times 2 over 2 times 1 over 2. That's going to give us 8 over 24, which is going to give us a decimal of 0.334. And that's not really clear. Let me rewrite that so you can see it. So you should get .334 for number 14. 15 through 15 through 19 deal with this marble problem. So it says the box contains 5 purple marbles, 3 green marbles, and 2 orange marbles. 2 consecutive draws are made from the box without replacement of the first draw. Find the probability of each event. So again, the important part in this problem is that it's without replacement. So these are dependent problems. So we need to find the probability for 15 that our first draw is purple and our second is orange. So probability of purple for the first draw. We have 5 purple marbles, and that's going to go over our total, which we have 5 purple and 3 green, that's 8, plus the 2 orange. So we have 10 total marbles. So our probability for purple is going to be the 5 purple marbles over the 10 total marbles. Now we need to find the probability of orange for our second draw. And remember, we didn't, assuming that we picked out that purple marble, we didn't put it back in the bag. So now we've taken out a purple marble, so we only have 9 marbles left altogether. But we still do have our 2 orange marbles. So we have a 2 out of 9 shot now of getting an orange marble. So to find the probability that our first was purple and our second is orange, we're going to take 5 over 10 and multiply by the 2 over 9. And we're going to get 10 over 90, which is going to give us a decimal of 0.111. For 16, we want to know when the probability of our first pick being green and our second pick being purple. So, probability of our first pick being green. We have 10 total marbles to start out with. 3 of them are green, so we have a 3 out of 10 chance of getting a green marble. And then our probability that our second pick will be purple. Now we know that we've taken out 1 of our marbles, so we only have 9 because we didn't put it back, because this is without replacement. So we still have our 5 purple marbles though, so we have a 5 out of 9 chance of picking a purple marble. So to find this probability, we're going to take 3 over 10 and multiply by the 5 over 9. We're going to get 15 over 90. Which is going to give us a decimal of 0.167. Number 17 wants us to know when our first pick is orange and our second pick is also orange. So we want to find the probability of our first pick being orange. So again, we start out with 10 marbles total. 2 of those 10 are orange, so we have a 2 out of 10 chance of picking an orange for our first pick. For our second pick, we also wanted it to be orange. So now, assuming that our first draw was an orange, we only have 1 orange left out of the 9 marbles that are left total.
Chris Garecki, if you're in the building, please come to the main office.
So to find our probability, we're going to have 2 over 10 times 1 over 9. That's going to give us a 2 over 90, which is going to give us a probability of 0.022. Number 18 wants to know if our first pick is purple and our second pick is blue. So probability of picking a purple marble first. We have 5 purple out of our 10 total. And then probability of picking a blue second. So we don't have any blue marbles in our original set. So you have a 0 out of 9 chance of picking a blue marble, because you don't have any blue marbles. So our probability is going to be 5 over 10 times 0 over 9. And we know that 0 over 9 is 0. So this equals 5 over 10 times 0. And anything times 0 is 0. So there's a 0% chance of both of these events happening. Of picking a purple marble first and then picking a blue marble. Number 19 is picking a purple first and then picking a purple second. So we need the probability of picking a purple first. So that's we have 5 purple to start with, and that's over our 10 total. And then picking a purple second, again, we're assuming that we picked a purple first and we didn't put it back in the bag. So we have 4 purples left and we have 9 total marbles left. So our probability of picking a purple first and picking a purple second is 5 over 10 times 4 over 9. When we multiply that through, we're going to get 20 over 90. And that'll give us a decimal of 0.222. 20 and 21. We have now a bag that contains 9 red chips, 6 red chips, 9 white chips, and 5 blue chips. A chip is selected at random and then replaced. Then the second chip is selected. Find the probability of each event. So these are independent events again, because we're putting the chip back after we've drawn it. So for number 20, we need to find that the first chip is not red and the second chip is not white. So probability of our first chip not being red. So we have 6 red chips, 9 white chips, so that's 15, plus our 5 blue chips. So we have 20 chips total. And we don't want our first pick to be red. So we have 9 white chips that it could be and 5 blue chips that it could be. So we have 14 chips that aren't red out of our 20 chips total. And then we want our second pick to not be white. So again, these are independent events, so we've put the chip back. So we still have 20 chips. And now we don't want our chip to be white. So we've got 6 red chips that it could be and 5 blue chips that it could be. So we have 11 chips that are not white. So to find our probability that we get not a red chip and not a white chip, we're going to take our 14 over 20 and multiply by our 11 over 20. And we're going to get a decimal of 0.385. For number 21, we want the first chip is green and the second chip is blue. So like before, probability of green, we don't have any green chips, so you have a 0 out of 20 chance of getting a green chip, which equals 0. Then our probability of drawing a blue chip equals, we have 5 blue chips out of our 20. So the probability of both of these events happening is 0 times 5 over 20. which just equals 0. And finally, number 22 says, suppose you have 7 CDs in a box. 4 are rock, 1 is jazz, and 2 are country. Today you choose 1 CD without looking, play it, and put it back in the box. Tomorrow you do the same thing. What is the probability that you choose a country CD both days? So we're choosing a CD and then we're putting it back. So these are independent events. So we need to find the probability of picking a country CD. So we had 2 country CDs, and that's going to go over our total number of CDs. We had 7 CDs total. So that's a 2 out of 7 chance of picking a country CD. And then for the next day, we also want to pick a country CD. And we put the first CD back, so we still have a 2 out of 7 chance of getting a country CD. So to find the probability that both are country, we're going to take 2 over 7 and multiply by 2 over 7. This is going to give us 4 over 49. And that's going to give us a decimal of 0.0816. So that's finding the probability of independent and dependent events. And we are done.